us what your names are.
Hi, I'm Peter Jones.
Hi, I'm Jordan Hawk.
Hi, I'm Joe Evans. I'm Zach Glasgow.
Hi, I'm Chase Gothier.
We are Team 5560 from Elk River, Minnesota, and here's our solution. In 2012, 3.1 million high school students graduated on time from United States high schools. Now, these students are expected to make a tough decision, whether or not to go to college, what to study, what to do with their entire futures. There is no one best path for every individual. As part of the M3 Challenge, we set out to create a set of models to help students answer these questions. We found out what the true cost of college was beyond the sticker price. We helped determine which degree would give the best financial stability and overall happiness. We evaluated these models with sample cases to make students more confident in their decisions.
For part one, we were asked to calculate the real price of secondary school, beyond just the college's sticker price. We then applied this model to a sample of 6 graduates. We defined the price of students would need to pay, P, would be equal to the college's cost, C, which include tuition and tuition inflation, housing and living expenses, transportation, and tuition reduction, minus the total financial aid granted to the student, which include Pell Grants and other outside scholarships. AP credits are a common source of tuition reduction in most cases. Here we considered 5 average AP tests taken from the College Board and found the most common scores for each, which we used in the next table. Here we calculate the p-values for 8 different colleges, 1 public and 1 private, from 4 different geographical areas of the United States, such as the Midwest and Southeast. Here we considered transfer credits, federal, state and local, and institutional grants. Tuition inflation occurs on all tuition, but it occurs differently for different types. Here we have considered 3, which we received from the College Board. And here is the average cost by type, which we used in part 2. In most cases, the student would need to take out a loan to cover the price of P if they are not immediately able to do so. We then define the actual price of students would need to pay, X, would be equal to P plus the interest accumulated on a loan, I.
Family contribution is what the student and his or her family can pay each year. The function alpha of n represents the portion of the money available that can be contributed to the student's college fund. AA represents available assets, while AI represents available income. Thus, we have 4 sources of money coming from the family: the parent's income, the parent's assets, the student's income, and the student's assets. We assume that the parents will contribute to each of their kids' college funds equally, and that the students will only contribute to their own funds. Therefore, we divide the parent contribution by the number of kids in college. The Department of Education recommends a contribution of 12% of the parent's assets, 50% of the student's income, and 20% of the student's assets. So we use those values. However, the most important factor is the amount of money that is available from the parent's income. A large proportion of the parent's income is used, though, and cannot be contributed. These expenses primarily include taxes, house and car payments, living expenses, and caring for dependents. We found tax data on the IRS's website, and for simplicity, we use regression to show estimated tax values. In our paper, we use logarithmic regression, which ultimately overestimated tax levels for high-income families. We fixed this by using logistic regression, which ultimately improved our results. We use a linear regression to approximate the cost of raising children. Wealthier families spend more money on each child, so they incur higher child care expenses. However, for a single-parent household, we allocated $400 per month due to extra costs that face single parents. In our paper, we assume a proportional amount of the income after taxes will be spent on housing, transportation, food, and other living expenses due to time constraints. This is because wealthier families have bigger houses and nicer cars, and then therefore have larger payments on them. According to CNN Money, 43% is the approximation of this value for a middle-income family. Now we have calculated how much the parent's income is available using this equation. The amount of money the parents will contribute will vary significantly based on the parents. Some parents will contribute no money, while some parents will want to help out as much as they can with the kids' college fund. Therefore, we will define rho to be the proportion of the available income the parents are willing to contribute.
if the family contribution is less than the price, the family will need to take out a loan. The size of the loan is the price minus the total family contribution over all years, or 0 if the family can pay the total price right away. To calculate the interest on this loan, we assumed a yearly interest rate of 4.66%, which is the interest rate of a Stafford loan. We also assumed a constant inflation rate of 1.38%. Since any inflation will make loans easier to pay off in the future, we will calculate the interest rate in real terms, which according to the Fisher equation is 3.28%. By using the general interest formula, we found the amount of interest the students will pay. For simplicity, we assumed the loan would be compounded annually. Also note that in general, the loan repayment period, T, is 10 years, in which case the student will ultimately pay 38% interest on the loan. And everything accounted for, here is our final model for part 1. For our sample cases, we made these assumptions you can see here, so we could fill in our model and make comparisons. Note that rho equals 0.5, so we are assuming that the parents will contribute half of their discretionary income to the student's college fund. In reality, they may contribute more or less. We also assumed 2 kids in college for the three-child family. We used a government calculator to calculate a Pell Grant for each of our example students and found their estimated family contribution, or EFC, according to the government. Our FC values are very close to the government, so our model is accurate. We wrote an algorithm to apply our model to several sample colleges with different total costs. Note that the top value in each cell is the total cost of the student's family, while the bottom value is the amount that just the student will pay. As it turns out, the people whose family will pay the most are the people whose family is in the middle class. The lower class families will pay less due to grants lowering their total costs, while upper class families will pay less because they will not need to take out as large of a loan. However, students from low-income families will be the ones actually paying for their education. Students from high-income families are best off because if their parents will foot a large chunk of their costs, they themselves will pay less. However, if the parents of an upper-class child choose not to contribute to their child's education, then that student will have to pay more than anyone else because they won't get any need-based grants. So the system heavily favors students with parents who pay for as much of their child's education as they can. On the other hand, lower-class students are at an advantage when they have siblings in college because they get larger grants without losing any of their generally negligible parent contribution to their sibling. However, middle and upper-class students are greatly disadvantaged by having a sibling because it hurts their family's financial contribution more than it helps their financial aid, therefore leading them to a larger loan and more debt. Also, our model suggests that the government expects too much from high-income families with many kids. Our personal experiences back that up as well, suggesting that this over-expectation is common. Finally, President Obama made a recent suggestion to make 2 years of community college free for students who maintain a 2.5 GPA minimum and are making progress towards a degree. If it went into effect, it would affect our model in a trivial way. We will simply not have to consider tuition in the processes of calculating C when his conditions are met. We will discuss his plan more in part 3.
Along with creating a model to evaluate the actual cost of pursuing higher education, we were also tasked with creating a model that would accurately assess the short-term and long-term benefits and liabilities of getting the following levels of education: STEM bachelor degrees, non-STEM bachelor degrees, associate's degrees, and high school diplomas. The factors we were asked to consider when creating our model were earning potential, which we effectively interpreted as the ability to accumulate valuable assets, and financial stability, which we interpreted as the employment rates in given fields. Some assumptions we made to evaluate our model were that inflation is negligible, that students would hold no job while in college, that upon graduating, students would go immediately into the workforce, where they would get an average job with average income in their field, and that occupations we selected accurately represent their respective categories. For our model, we define the measurement economic standing as the product of an individual's net worth and their field's employment rate. We defined net worth as the difference accumulated over time between the cost of the salary and the cost of living minus the total sum of the debt they accrued while in college. And employment rate is simply the quotient of the number of people employed in the field and the number of people in the field. To evaluate our model on the challenge day, we had to create a universal case. For that case, we used an individual who came from a 2-parent, 3-child household with an annual income of $75,000. And then for the cost of any bachelor's degree, we used the cost of a public 4-year university, which we evaluated from part 1. The intervals we defined as short-term and long-term were 10 and 25 years respectively. And then for any data we got on employment and salary statistics, we used the Bureau of Labor Statistics May 2009 report because we felt that conditions during the recession most accurately represent true financial stability rather than conditions during a relatively good time. The results are that after evaluating our model in a number of sample cases using popular occupations from each category, as you can see here, we found that the levels of economic standing ranked as follows. So for the short term, it was STEM bachelor degrees in the lead, followed by high school diplomas, then associate's degrees, then non-STEM bachelor degrees. And then for the long term, it was STEM bachelor degrees in the lead, followed by non-STEM, then associates, then high school diplomas. Overall, while the college graduates' initial debt first caused them to fall behind those with no degree, except for the case in the STEM bachelor degrees, we found that in the long term, the raised salaries and higher employment rates allowed those with degrees to far surpass those without.
In part 3 of our challenge, we created a model to evaluate the effect different educational paths will have on one's overall happiness. The factors we considered this were the debt and income from a particular education path, as well as the happiness, which could be directly attributed to the income they make. We also considered job satisfaction in their particular field. Some assumptions we had to make include that a worker without any college education will get a job directly out of high school that will pay $10 an hour, and they will not get a raise for the rest of their life. Individuals will all work full-time and will all sleep 8 hours per night. To approach this problem, we decided that each career path will have different levels of happiness for different individuals. This depends on what the individual values and what they look for in a job. We're also able to quantify the happiness which could be driven from usable income, and that the debt from education will reduce the usable income for an individual. Thanks to a Princeton University study from 2002, you can see the correlation between income and overall happiness levels. As you can see, that data was approximately logarithmic with an R-squared value of 0.71. This is a moderate correlation between income and happiness, and 71% of the variation of the data can be explained by our regression line. We calculated that an individual will spend 36% of their waking time at work and will spend 64% of their waking time freely on leisure activities. Using this, we created our model, with Q of C being the quality of life driven from career path C. We have W, which is the satisfaction from a time spent at work, with an expected value weighted at 36% of an individual's time. The remaining 64% of an individual's time is based on their happiness driven from usable income, with S being the average salary for a given career path, and loan being the payment to be made on debt incurred. I should mention about W, this is based on a possible score of 100 and is rated on an inventory of questions we have. Some sample cases we have are 2-year certificate versus no further education. If an individual has the same W value for both cases but would earn $36,000 with a 2-year certificate versus $20,000 per year with no further education, you can see there's not a significant difference under the current plan between the two paths. However, if Obama's plan were implemented and this individual were to qualify, there would become a significant difference between the two paths, and college would be worth it for this individual. Therefore, Obama's plan makes college worth it for certain individuals, where under the current system it is not. Another sample case is an individual choosing between a high-income job and a high-satisfaction job.
2 minutes.
Yes. An individual will earn $15,000 more per year in the high-income job, but will have 50 points higher W rating for the high-satisfaction job. As you can see, the high-satisfaction results are much higher than the high-income results. This is due to the logarithmic nature of income. So finally, we realize this model is a capable tool to compare career paths. It should not be used as a standalone and cannot be used to compare paths for different individuals, because individuals' W value is subjective. Also, a significant difference between career paths needs to be seen with a threshold of 5%. We determined that if it was any less than 5%, any variation could be explained by our moderate correlation with our regression line. Also, to make our model more comprehensive, we would like to add a test of ability in a particular field using either ACT subscores or a plan test. So in conclusion, in part 1 we found the true cost of college, and we realized students must be aware of the actual debt they will accrue. We also found that students need to be able to compare the costs of different colleges, and that the government expects too much from us. In part 2, we compared different degrees and found that STEM bachelor's degree gives the best payoff in the long run. Also, that in the long run, college is financially worth it for most individuals. In part 3, which is how career choice affects one's happiness, we realized that happiness can come from many different paths and truly depends on the individual. Also, that high income may not always be the best option for everyone. We thank you very much for this opportunity. The floor is now open for questions.
Ben, you have a question?
Sure, yes. So thank you, first of all, for your presentation, going first. It's always hard to be the first and get to go up there and make things happen. Yeah, so what I wanted to ask about is, you certainly identified and found this correlation somewhat between income and some happiness, right? There's a little bit of a relationship there. But then also, when you talk about identifying the true cost of college and talk about how students start to, they accrue loans, right? They choose their loans and they accrue loans. I was wondering if you could speak a little bit more about differences that would occur in terms of different repayment options for these loans, because it seems like that will significantly affect some of the things you were talking about as you progress through your model.
Yeah, for part one, we simply assumed a constant inflation rate, but in some cases, if students are gathering even more debt, then they would have to either take out a public or like a private loan, which will have a higher interest rate. So it really benefits the students who have the option to take out the government's really low interest rate loan, the subsidized loans. And then students who have more debt will have to turn to private loans, which will ultimately increase their total amount of interest they have to pay on that loan. So.
And for how it would affect our Part 3 problem, it's the payment on the loan would change, which would change the income, which could be directly attributed to happiness. So depending on that payment in particular would be what they could attribute to happiness. So it, I guess, depends on how much they're paying per month versus how much that debt they actually have, and that would depend on their payment program.
Thank you.
So there was definitely a short time period during which you had to work on this problem. And one of the things that you did not consider that maybe you would have had you had more time would be students that change major, or students that just in general take more than 4 years to complete college. 5th year is not unusual. So how do you think that would change your model and your conclusions?
For part one of our variables is actually like the amount of years they're attending college. So that one, it wouldn't really change the model in part one. For part two, it would make college slightly less financially worth it. It might actually be a tipper, like be able to flip it between different career paths, because they'll be paying more money, and that makes college slightly less the better option.
And then for part 3, I think this is in the way. There is the difference that it would change for the career path, but part 3 really assumes the long run. So if an individual would have more debt, there, like I mentioned earlier, there would be a higher payment and lower income, which could be used for happiness, but also that if the longer time period is not necessarily something to consider in part 3, it's more of a very much long run situation.
Thank you.
Yes.
You considered a logarithmic fit. Did you try anything else?
Yeah, we like for the first part or for the happiness.
The happiness part.
No, we didn't try anything else.
Mm-hmm.
We could have.
Why'd you pick a logarithmic fit?
It had the lowest R squared. That's why we picked it.
Mm-hmm.
I think the other candidate was a logistic regression, but we really didn't have that much data to work with because the max income was $60,000 on that data table.
Mm-hmm.
So,
given more time, we would have liked to find a more solid study with a broader scale, or even ideally create our own study, having a system of questions and pooling a bunch of individuals to find the true relationship between the two. Also, that study was from 2002, and we would have liked a little more recent data because that doesn't consider inflation. The $60,000 in 2002, 13 years ago, is not the same as the $60,000 nowadays, and we recognize that as one of the weaknesses of our model and would like to find more comprehensive data.
Thank you.
Just stop time.
Anything else?
Do we have time for another question?
One more.
I think in part 1 you did consider inflation, and then part 2 you said inflation was negligible and you held wages constant. How valid are those assumptions?
Okay, so we sort of failed to stress the fact, but in our model we used an integral, so we were trying to use inflation or salary as more of a function than a constant over time. And we also assumed that, like with the inflation, the salary would go up right alongside the cost of living, so that was why we assumed inflation was negligible. But to modify our model, we would like to use salary as a function over time, and then also we'd like to raise the entire quantity salary minus cost of living to the inflation rate over the time as well.
Also, ideally, something about wages being sticky and not necessarily rising with inflation exactly, so that would be something to consider.
Thank you very much.
Thank you.